start with video lesson 2 on dynamics, and the very first thing that we will see today is that is known as the equilibrium question. So a typical question on the equilibrium is when we have an object that is tied with two strings, string 1 and string 2, that are forming a certain angle with the horizontal line. So let's say that this is string 1 and this is string 2, and the angles are, let's suppose 32 degrees and 41 degrees with the horizontal. And the mass of the object is, let's say, 12 kilograms. So this is that we talked yesterday, the situational diagram. The conditions that, or the assumption that we do on this case is that the object is not moving. So no wind is affecting the motion of the object. And there is no elasticity into the strings of the object. Okay, so it's not that the object is or the strings are extended as a result of tied up with a mass, with an object that has a mass. So they don't stretch or they do not compress as a result of the mass hanged into the object. So now let's create the free body diagram. So a diagram, as we said yesterday, that is free of the object, and what do we see is only forces. So the object, we mentioned yesterday, is represented by a dot, where all the mass of the object is concentrated on that dot. And then from this point that is representing the object, we will draw all the forces that the object is experiencing. So we have to think here. We have to pause for a moment and then start drawing the forces. We always start with the universal forces. And the universal force that you will see in Physics 20 is force of gravity. Force of gravity always is toward the center of the Earth. And when we draw the free body diagram, when we draw the force of gravity on the free body diagram, we always start from the object and then we go down toward the center of the Earth. So the magnitude of the force of gravity is mass times acceleration due to gravity. And in our case, since the mass of the object is 12, will be 12 times 9.81. So 12 times 9.81 will be equals to 117.72 newtons. And then the other forces that we have here, since we have a or a string that the object is tied with, then we have the tension. And then what do we have is actually tension 1 that kind of replaces the string 1, and tension 2 that replaces string 2. Now, as we mentioned yesterday, the rule for tensions is starting from the object going along the string. So as the string goes, the tension will go. What we are saying here is that this line that represents string 1 is parallel to the line that represents tension 1. So this is telling us, is giving us the right, mathematical right, to say that the angle with the horizontal for tension 1 is the same as the angle that string 1 is creating with the horizontal. And the angle with the horizontal with tension 2 is the same as the angle that string 1 is creating with the horizontal. Is this clear? Now, since the object is in equilibrium, it's not moving. It's not moving. That gives us the right to say, based on the first law of Newton, that force net is equal to what? On the chat. It's equal to 0. But what did we say about force net? Force net is the vectorial sum. Force net is a vectorial sum of all the forces that the object is experiencing. Okay, so now in our situation, what do we have is force net is force of gravity plus tension 1 plus tension 2. Those are the forces that we have into our free body diagram. And this, since the object is not moving, is equal to 0. Understood? So now this has turned out to be adding vector questions, because this is a 2D situation, meaning that they form a certain angle with horizontal or vertical. Therefore, what we do is we will use components. So we will create that table that horizontal and vertical component of each of them is plotted in. So each of the vectors, horizontal and vertical. So we'll have force of gravity, tension 1, tension 2, and force net. So the horizontal component of force of gravity, since it is a force that is going, let's say, south, will be what? 0. The vertical component of force of gravity, since it is going down, will be negative 117.72. Even if you say 118, it's fine. Now, tension 1 is a force that looks like this, 32 degrees. So the horizontal component of tension 1 is this vector here, T1 horizontal. And the vertical component is this vector here, T1 vertical. Okay? But we don't know the magnitude of T1 nor T2. This is what we are finding on this question, if it was not clear. So, however, what do we know, since horizontal component is the adjacent, will be equals to whatever is T1 times cosine 32 degrees. And since the vertical component is the opposite, will be whatever is T1 times sine 32 degrees. And they are both positive on this case. So T1 will be positive T1 times cosine 32 degrees. And the vertical component will be positive T1 times sine 32 degrees. So it looks like when you have sine and cosine, it looks like you have one variable more there, but actually it's not true. If you type in your calculate or cosine 32, you will have a number. And for T2, that is a vector that is between north and west with 42 degrees, or 41, I think it is, 41 degrees. The horizontal component of T2 will be a vector that goes like this. T2 horizontal. And the vertical component is a vector that goes like this. T2 vertical. So T2 horizontal is adjacent of this right angle triangle here. And therefore, when we are finding T2, are you listening to me? When we are finding T2, then we will use cosine. But since it is in the west direction, means that is negative. So T2 horizontal component will be negative T2 times cosine 41 degrees. And the vertical component, it's going north, so will be positive T2 times sine 41 degrees. Agree? What we are doing on every single time when we are adding vectors, we are adding the component on the horizontal and adding components on the vertical. So this is what we have here. T1 cosine 32 minus T2 cosine 41 is equal to, we said that force net, since it is in equilibrium, is 0. And a zero vector has 0 components, horizontal and vertical. A 0 vector has its components are 0. So then what we have here is we have 2 equations, one for the horizontal and one for the vertical. So we have one equation that is T1 cosine 32 minus T2 cosine 41 equals to 0. And then T1 sine 32 plus T2 sine 41 equals to 117.72. Does this make sense? I have to record it. When we are saying the object is in equilibrium, that means that the object is not moving. Therefore, acceleration is 0. And even based on the second law of Newton, force net times is equal to mass times acceleration. Since acceleration is 0, then force net is equal to 0. So this is the first case, equilibrium. Keep this in mind even on physics 30. When we are saying that the object is moving with constant velocity, that means that acceleration is 0 again, based on what we learned in kinematics. Therefore, force net is equal to 0 as well. And then when we are saying that the object is at rest, the object is not moving at all, again, acceleration is equal to 0. So those are the 3 cases that you have to keep in mind. Say that force net is equal to 0. Make sense? By writing those equations, equation 1 and equation 2, what do you have actually is a system with linear equations in which the variables are T1 and T2. How do you solve this is totally up to you. I will show you both ways, mathematical way and using the calculator. Which one would you write? It doesn't matter to me. Both of them are fine. So let's start with the mathematical way first. From equation 1, I will solve for one of the variables. Which one? I will say T1. So then equation 1 is converted now into T2 cosine 41 over cosine 32, 1 prime. And I will take this relationship and substitute it into equation 2. So where I see T1, I will substitute it with this relationship. And I see T1 on the very first term, so I will use a different color so that you can. So T2 cosine 41 over cosine 32, and this is just for T1, times sine 32 degrees plus T2 sine 41 equals to 117.72. Do you have any question on this? Okay, so now just to simplify it a bit. As you see here, what we have is sine 32 over cosine 32. So sine over cosine is tangent, but if you cannot see this, still it's fine. So now T2 times cosine 41 times tangent 32 plus T2 sine 41 is equal to 117.72. The common factor here is T2. So if you factor out T2, then you will have cosine 41 times tangent 32 plus sine 41 equals to 117.72. And from here, T2 will be 117.72 over all this expression here. Cosine 41 times tangent 32 plus sine 41 degrees. And now in your calculator, let's see what T2 is. It's 104.39 or 104.4 newtons. Because it's a force. We are talking T2 as being a force. Okay? Because everyone has this. And now with this value, what we can do is we can find what T1 is, because we said that T1 was T2 times, let me bring it again, the relationship that we had here. T2 cosine 41 over cosine 32. Cosine 41 over cosine 32 degrees. So this will be the same as saying 104.4 times cosine 41 over cosine 32. So in your calculator, it's 92.9 newtons. So then after this, you can say the tension on the first string is 92.9 newtons. This is the magnitude. If you want to give the direction, you can. And it's the same as saying that it's at 32 degrees north of east. And T2, we usually do not give the direction for the tension because it is the same direction as the string. So we just usually say magnitude is 104.4 newtons. And in general, the direction for the tension is not asked. Question: the calculator, what we are doing, what we are keeping in mind is that the T1 and T2 has to be at the same column. So when we are writing the equation, we have T1 cosine 32 minus T2 cosine 41. On the second equation, we should have T1 again and T2 under T2. Okay, so now what we do is we go to matrix. So second function matrix, and then we will create a matrix. So we'll enter the information into the matrix. The very first thing that the calculator is asking is saying, how many rows and how many columns do you have? So you have 2 rows, 2 equations, and we have 3 columns. So the matrix will be 2 by 3. What you will see is some a view like this. And now the calculator is asking you, what is the first coefficient? So if you keep in mind the first equation, the equation was T1, which is a variable that we will find, times cosine 32. So, and make sure that the mode of your calculator is on degrees, and then enter the coefficients as you see in your equations. So it is cosine 32 is the first coefficient, and then the calculator calculates it itself. The second coefficient, or the second term, is negative T2 cosine 41. So the variable is T2. Everything else, including the negative, is part of the coefficient. So you go negative cosine 41 degrees, and then enter. As the third term in the first equation is 0. So it is 0 there, and you move to the first term on the second equation, which is sine 32. Enter. And then the second term in the second coefficient on the second term of the second equation is sine 41. So sine 41. Enter. And then the last term is 117.72. And then you enter. Is this clear? Okay. And then after that, after you enter the information that you have from the equations, then quit and go back to matrix. Now, math, and go down to RREF. This one here, which is the B option. And the calculator is asking you which matrix do you want to solve. And you will enter the matrix that you have entered the information from. Usually I pick always matrix A, but it may be a different matrix. So now it's after you pick the matrix that you entered in, then you click enter, and then you see whatever variable you had in the first column, which for us was T1, is equal to 92.9. And whatever variable you have in the second column is 104.39, or 0.4 that we have. So this is, again, why it's important to have the variables in the same in the same column. So T1 under T1, T2 under T2, not mixing them up.